Howdy, welcome to MMET 370. This is Lab 9. The title is Steam Turbine. It's a Rankine cycle experiment. It's also called the Thermal Power Plant Lab activity. The objective of this lab is to understand the operation of a Rankine cycle used in thermal power plant to produce power. And we are to perform system performance calculation using first law energy conservation equation for steady state and steady flow conditions. In this slide, you can see the schematics of the Rankine cycle. This cycle contains 4 major components: the pump, the boiler, and the turbine. And in it, they have different processes, which we're going to talk about in the next slide. In the previous slide, we discussed about the 4 major components associated with the ideal Rankine cycle. And from this TS diagram, we could see that the ideal Rankine cycle has 4 major processes. The process 1 to 2, which occurs in the pump, is an adiabatic process. That's the isentropic compression in pump. And the process 2 to 3 from the TS diagram is the isobaric process. This is a reversible constant pressure heat addition in the boiler, and where the liquid water is being heated up in the boiler and gets to superheated steam. The process 3 to 4 is an adiabatic process where there's an isentropic expansion in the steam turbine. And lastly, the isobaric process occurs isobaric heat rejection, where there's a reversible constant pressure heat rejection in the condenser. So there's where liquid water is condensed and moved back to the pump, where the process is adiabatic and reversible. This is the experimental setup for the Rankine cycle. At the top right or bottom corner, this is a liquid propane tank and the fuel cells we use to power up the experimental setup. In the Rankine cycle, we have a lot of devices. We have the boiler, we have pressure gauges to help us to monitor the pressure building up at the boiler. We also have the turbine, the generator, the steam admission valve. We have the condensing tower. We have for the monitoring devices, we have the ammeter, voltmeter help us to regulate, and the load rheostat that help us to regulate the load when we switch up the load at what the time that the turbine is running. There's a key master switch, and we also have data monitoring software, the NI, that help us to collect data when the experiment is running. And we use this data collected for data analysis. So this experimental setup is ran to perform analysis for steady states and steady flow conditions. We would do a demonstration to enable the student to learn and how to conduct this experiment safely and in a safe and efficient manner. Howdy, this is MMET and we want to talk about the Rankine cycle, and we can also call this the steam turbine power plant lab activity. I will do a demonstration of how to set up this lab experiment. First thing I do is to connect the fuel source before closing. So this is the fuel line, and there's a propane tank which we use. So you connect this lead here to the propane tank, and you use a wrench to lock it up. So when you lock it up, you would wait for some time. The next thing you do, you want to use the beaker here to fill some water. You top the beaker to 5,000 ml, and you drain it to the boiler. So this is the boiler, is the fire tube boiler that we have in the Rankine cycle. This boiler here, at the back of this boiler, we would have where we would touch. We tap this place and we're able to drain out the whole water into the boiler of this system. The next thing we do, we want to turn on our master key. We turn on our master key and we switch up the burner. So this burner here can help us to ignite this burner. This burner will help us to ignite, and it waits for some time. It kicks off and the water starts heating up in the boiler. And with that, we can use our laptop, the software embedded in it, so we're able to monitor what's going on inside the system. So there's always a connected laptop here that's going to be placed here. Connect the laptop, it helps us to monitor the built-in pressure inside the boiler. So we want to achieve the pressure of 120 psi. So this can take up to 2 to 5 minutes for us to be able to achieve that pressure. By the time we get to that pressure, there's a steam admission valve. If you come closer, this steam admission valve, it should be in a closed position. Okay, it's in a clockwise motion. We put it to a closed position while the pressure is building up. Okay, we put it in a closed position. I try to turn this. It's in a closed position. So by the time the pressure gets to 120 psi, okay, we can see a lot of the indicator, if you give pressure, starts having some found disturbances. That's at that point you start releasing the steam admission valve gently to allow entrance of steam. Okay, that little entrance of steam, you can also monitor it from the system. What are we trying to monitor? We are trying to monitor one, built-in pressure in the boiler, and also elevated temperatures. So because we need steam power to be able to turn to power up the turbine. So this can take more time. By the time we can measure the temperature in the software, it gets up to saturation temperature and it builds up to superheated steam. When we have elevated temperatures ranging from 160 to 180, we can start regulating the steam admission valve gently. We start regulating it gently. By the time we wait for some time and there's enough steam power for elevated temperature up to 180 degrees C, we will be able to observe that the turbine will pick up. It will pick up. The turbine will start running. We can also see the power of that turbine by there's a shaft in between the turbine. The shaft in between the turbine starts moving, and this shaft is connected to the generator. The generator itself is the load that is connected from the turbine to the generator. That's the energy conversion from turbines is mechanical equipment and the generator is electrical equipment. So from mechanical energy to electrical energy by aid of the shaft. At that time, we also quickly open up more steam to give more power to the turbine. Then we go to our load. Then we try to switch up our load. Okay, switch up our load, and when we switch up our load, we use the load rheostat. This is the load rheostat to monitor the amperage and the voltage of this steam turbine power plant. We can use this to regulate, and over here we need to get within the range of, you monitor and regulate 6.6 volts at this voltage regulator. You can also monitor up to 1 amps to 2.2 amps. So this will give you the current and this will give you the voltage. You use this to regulate. It shouldn't exceed that range. At the time you are regulating it, you start up data collection from the airline instrumentation panel. Use that to get enough data while the system is in steady state. At the end of these experiments, students are able to realize the processes of this Rankine cycle, from heated water in the boiler, steam coming off at elevated temperature to the turbine through the aid of the steam admission valve, gives power to the generator, take up load, and the steam goes to the condenser, and the condenser takes off the hot water liquid and condensing it to low water liquid. Since it's a reversible cycle, it goes back. But because of its system, we need to drain out the water at the end of each experiment. We also drain out the boiler at the end of the experiment to make us to have the system to be efficient as possible. So this is all you need to know for this experiment. Thank you.